Okay, with that, we can start our second session, measuring instrument. Okay, we have done up to vernier caliper and we have discussed about the vernier caliper in our last class. Okay. Now, here there's a vernier caliper. Now tell me, what are those parts? Correct. There are vernier caliper. Now you can identify, you have to identify those parts and tell me. What is this?
Jaws.
Sorry?
Internal jaw.
Internal jaws. What are those?
External jaw.
Okay. This one.
Rod.
Oh, very good. This one.
Wheel.
Wheel. I think there's a small leg. Right? Then, what is this? This one?
Nut.
Yes, not. And then, what is this one?
Vernier caliper.
No,
What is a vernier scale?
it's scale. Okay. This is this one?
Main scale.
Main scale. So this part, this entire part,
Sliding jaw.
sliding jaw. This entire part, this entire part,
Fixed jaw.
fixed jaw. Okay. Okay. Those are the components of vernier caliper. And you can clearly see when the two jaws are in contact, the zero mark of the vernier scale should coincide with the zero mark with the main scale. Okay. If there is no error, definitely both zero marks should be coincide when the two jaws are in contact. Okay. So if so, there is no error. But in some cases, those two marks are not coincide each other. Okay. That means if they are not coincide, that means they definitely the vernier caliper has already shown a reading. And therefore, in such cases, we call them as an error. Okay. So this is a special name for that error. It is zero error, because when the two jaws are in contact, two zero marks should be coincide each other. If not, that is called as a zero error. Okay, now write a topic. Zero error. Zero error. Zero error. Zero error of a vernier caliper. Zero error of a vernier caliper. Look at this one. Suppose now this is the main scale. This is the main scale. main scale. This is 0 mark. 1, 2, 3, 4, 5, 6. And if this caliper doesn't have an error, definitely the vernier 0 should coincide with the 0 mark of the main scale. 0 mark of the main scale. But, so this is the one scale. So in this case, there is no error. In this case, there is no error with it. This is no error condition. No error condition. But suppose vernier caliper, suppose the vernier mark is shifted little bit to the right hand direction. Suppose the vernier mark is shifted little bit into the right hand direction, then what will happen? Now here the main scale 1, 2, 3, 4, 5, 6. Now the vernier mark is shifted little bit towards this side. Zero, 1, 2, 3, 4. So that means this vernier mark has shifted a little bit towards this side. That means this scale is already shows a reading put it. This already shows a reading. If there is no reading, both scales, both 0 mark should be coincide. But if it is shifted a little bit into the right hand side, then definitely there will be a reading here. There will be a reading here before starting to measure. So this would be an error. This would be error. This would be error. Therefore, this kind of errors are called zero error putting. This can be happening in other way. That means, suppose this is the main scale. This is the main scale. 0, 1, 2, 3, 4, 5, 6. And the vernier scale can be shifted into the left hand side too. Okay, into the left hand side. So if it is shifted left hand side, then this kind of thing can be happen. And now this is shifted towards the left hand side. And this one is shifted towards the right hand side. This one should be shifted. This one is shifted. This one is shifted into the right hand side. This is scale. This one is scale is shifted to the left hand side. And vernier scale. Vernier scale is the main scale. Make a shifted in main pattern. Right hand side. Now the vernier scale is shifted to the left hand side. Vernier scale shifted to the left hand side. This is vernier scale. This is vernier scale. This one is the main scale. So both are called as zero error. Both are called zero errors. Zero errors. Okay. Actually, Pute, if this kind of error is here, this is called as positive zero error. Positive zero error. If the vernier scale is shifted towards the right hand side when the jaws are in contact, when the jaws are in the contact, if the vernier scale is shifted towards the right hand side, then this kind of error is called as positive zero error. When the two jaws are in contact, the vernier scale is shifted towards the left hand side. This kind of zero error is called the negative zero error. Negative zero error. And actually, this is very easy to remember. You know, if you consider about x-axis, the positive side is the right hand side. The negative side is the left hand side. Ne? If you consider about x-axis, the positive side is the right hand side. Negative side is the left hand side. Therefore, right hand side means positive, left hand side means negative. Okay. Therefore, if the vernier scale is shifted to the right hand side, then the error is positive. If the vernier scale is shifted towards the left hand side, then the error is negative. Okay. Did you get my point? Then,
Yeah, sir.
okay, others? Anything on? Okay. Then write a topic, zero error, zero error, zero error. Okay, note down this, Pute, note down this. When the external jaws, when the external jaws when the external jaws when the external jaws of a vernier caliper are in contact, the zero marks of the zero mark of the zero marks of the zero marks of the zero marks of the zero marks of The main scale and the vernier scale, the main scale and the vernier scale should be coincided each other. Should be coincided each other. Should be coincided each other. Should be coincided. If they are not coincided, if they are not coincided, then the caliper is said to have a zero error. Then the caliper is said to have a zero error. Then the caliper is said to have a zero error. If any caliper, have a zero error, if any caliper have a zero error, if any caliper have zero error, the obtained reading, the obtained reading the obtained reading will be either less than or more than the corrected value. Will be either less than or more than the corrected value.
Excuse me, sir. Less than or more than?
The corrected value will be either less than or more than the corrected value. There are two types of zero errors. There are two types of error. There are two types of zero errors. There are two types of zero errors. Based on the direction, based on the direction, based on direction, where the vernier scale has shifted, where the vernier scale has shifted, based on the direction where the vernier scale has shifted. Okay. Now you can draw these three images. The first one, no error condition. The second one and third one have zero errors. But in the second one, the vernier scale is shifted towards the right hand direction, therefore it is positive, zero error. In this case, it is shifted to the left hand direction. So the negative. It is easy to remember if you can remember the positive or negativeness of x. X coordinate. X axis again positive again right hand side. If you consider about x axis, positive means right hand side, negative means left hand side. Positive means right hand side, negative means left hand side. The same sign convention here. Okay. Then next topic. The next topic. How to correct the zero error? How to correct the zero error? That is topic. That is the topic, Malik. How to correct the zero error? Can anyone give me a suggestion? Can anyone give me a suggestion? If we consider about this instance, can anyone give me a suggestion? What to do? No. Consider the both. Consider both may zero errors and tell me a common solution to correct the observed reading. How to correct that one? Ethan? Ethan again put up there. Reduce the correction. Both cases? No, I mean how to correct that one. How to correct that one? That means how to correct. So reduce the correction means how there is a correction of the. So how to correct that one? Then we can decide whether it should be reducted or added. By adding and subtracting. What? Adding and subtracting means what?
Sir, the vernier scale is movable, so we can move it to the 0.
You have to do one more thing. We can decide whether it should be added or subtracted. But before that, you have to determine how much distance this is shifted. Then you have to decide, actually, you have to determine the shifted distance. You have to determine the shifted distance first. That is the one. That is the only thing you have to do. You have to determine the shifted distance. And the you have to determine the shifted distance. Actually, initially, if there's no zero error, both zeros should be coincided. Both zeros should be coincided. Now they are not coincided because the vernier caliper is shifted. So the error is equal to that shifted distance. The error is equal to this shifted distance. So you have to determine that shifted distance. Then we can determine whether it should be added or subtracted. Did you get my point? Huh? Did you get my point, Putin?
Yes, sir.
Therefore, to correct. What did I do, Putin? Okay. 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 If there's no zero error, definitely two zeros of main scale and the vernier scale should be coincident. Now, if there's a zero error, the vernier caliper is shifted either in right hand direction or left hand direction. Therefore, the error is equal to this shifted distance. No, the error is equal to this shifted distance. Therefore, error, you have to find that error. That means you have to find the shifted distance of the vernier scale. Vernier scale. Find out the thing. Yes, very good. Very good. That's it. Write down this thing. If there is no zero error, if there is no zero error, both scales should be coincided. Both scales should be coincided. If there's an error, if there is an error, if there is an error, the vernier scale will be shifted, will be shifted will be shifted either in right hand or either in right hand or left hand directions. Either in right hand or left hand direction. Therefore, okay, then you can write down this thing under that sentence and therefore, the error is equal to the shifted length of the vernier scale. The error is equal to the shifted length of the vernier scale. It is equal to the shifted length. It is equal to the shifted length of the vernier scale. This one is equal to the shifted length of the vernier scale. Okay. Now we know, actually we have learned how to determine the shifted length of the vernier scale. That was learned, I think, no, I think 2 weeks ago, no? And how to determine the shifted length of a vernier scale. How to determine the shifted length of a vernier scale? How to determine? කොහොමද ඒක determine කරන්නේ?
So the
Huh?
coincide value of the vernier scale.
Coincide value of the vernier scale into the least count. Into the least count, නේ? මොකද value එක? Look at this one. Again, I will explain. Suppose this is the main scale. 1, 2, 3, 4, 5. Now this is divided into 6 corresponding values. 1, 2, and 0, 1. Make it one scale, okay? Make it any. Okay, look at this. This one is equal to D. Eh? This is a least count. This is the least count. And this distance is equal to 2 times D. This distance is equal to 3 times D. This one is equal to 4 times least count. And this one is equal to 5 times least count. 5 times least count. And therefore, if the vernier scale is shifted, if the vernier scale is shifted by simple d distance, then both 1 marks will be coincide each other. Then, if the vernier caliper is shifted by 2d distance, then this mark will come to this location. Then, both the second mark, the second mark of the vernier scale is coincide with the main scale. If the vernier caliper is shifted by 3D mark, so 3D distance, then the third mark of the vernier scale is coincide with the main scale. It is no matter regarding the values in the vernier scale. And a value එක 1 වුණත් එකයි 2 වුණත් එකයි 0 වුණත් එකයි. There is no matter. But you have to consider about this one. 1, 2, and 3, 4, 1, 2, 3, and 1, 2, 3, 4, 5, 6 in the main vernier scale. If the first mark of the vernier scale is coincide with a scale with a mark of the main scale, then that means vernier scale is shifted by simple d distance. And if the second mark of the vernier scale is coincide with the scale of the main scale, with the mark of the vernier scale, then that means the vernier scale is shifted by 2d distance. And I think if the fourth mark of the vernier scale is coincided with the mark of the main scale, that means the vernier scale is shifted by 4d distance. And therefore, using this method, you can determine the shifted distance of the vernier scale. That means you can determine the error using this method. And now tell me, what is the error of this scale, of this in this time? What is the error?
2D. 2D.
Devaling kiya, yes, devaling kiya. What's falling? This one. The second mark is coincide. It is 2D. It is equal to 2D. The second mark of the Vernier scale, the second mark of the Vernier scale is coincide with the main scale. Therefore, it is shifted by 2D distance. Yeah. Did you get my point? No? I will tell you. Look at this one again. Everyone, please listen to me very carefully. Everyone, please listen to me very carefully. Look at this one. If I shift the Vernier scale by d distance, then what will happen? This will come to this location. This will come to this location. There. Are you clear with me? Is it clear? If the Vernier scale shifted by d distance, then the first mark will come to this location. Is that clear? Is that clear? If the Vernier, how clear is it? Clear is it?
Understood, sir.
Others? Anita, what are Oh yeah. That means if the Vernier caliper is shifted by d distance, this mark will come to this location. If the Vernier caliper is shifted by 2D distance, then what will happen? 2D distance means all are shifted by 2D distance. Then what will happen? This mark will come to this location. This mark will come to this location. If the Vernier caliper is shifted by 3D location, 3D distance, this mark will come to this location. Therefore, on the other hand, if you can see the first mark of the Vernier caliper is coincide with the main scale. That means the Vernier scale has shifted by d distance. If you can see the fourth mark of the Vernier caliper is coincide with the main scale, that means it should be shifted by 4D distance. So according to that argument, you can clearly see the second mark of the Vernier scale. The second mark of the Vernier scale is coincide with the main scale. Don't need to worry about the mark of the second main scale. Main scale के mark के गणन करने पर मेरे का consider करना. Second mark of the Vernier scale is coincide with the main scale. Therefore, the shifted distance should be equal to 2D. Did you get my point? Therunada?
Yeah, sir.
Thank you, Ute. Himashan? Devdu?
Yes, sir.
Thank you, Ute. Therefore, in this case, error should be 2D. Error should be 2D. That is positive. 2D. Now tell me what is the error of this in this case. What is the error in this case? One, two, three,
3D distance. 3D.
Negative.
Sir. Again. I come on. Nah, mana kamu nonton itu kan? Ini kan itu kan? Not it.
Negative 3D, sir.
3D.
Negative 2D.
Wait. Okay, tell me, what is the shifted distance? Tanggal again.
Minus 2D.
Minus 3D.
So minus 2D, is it correct?
How are you? You cannot get that get this value as in the previous case. You have to measure the shifted distance. Look at this one. If it is a negative zero error, if it is a negative zero error, the vernier caliper is shifted into the left hand side, not into the right hand side. Okay, it is shifted into the left hand side. Look at that one. That's why I have mentioned earlier the error. The error is equal to the shifted distance, not into the reading. It is not equal to the reading. It is equal to the shifted distance, shifted length. So now you have to determine the shifted length, shifted length. Now in this case, the vernier caliper is shifted into the left hand side, left hand side. So look at this one. Therefore, if the vernier caliper is shifted left hand side, look at this one. Look at this one. Now this distance is equal to D. This one is equal to 2D. This one is equal to 3D. This one is equal to 4D. And this distance is equal to 5D. Therefore, if this vernier caliper is shifted into this direction, what will happen? If this mark coincides with this one, that means the vernier caliper has shifted by simple d distance. If this mark, that means fourth mark, the fourth one, is coincide with the main scale, that means the vernier caliper has shifted by 2d distance. If the third mark is coincide with the main scale, that means the vernier caliper has shifted by 3d distance. Did you get my point? There.
Yeah, sir.
Very late. Kata konyang tak. බලන්න මම ඒකයි කිව්වේ පුතේ අනිවාර්යෙන් හොඳට තේරුම් ගන්න කටපාඩම් කරන්න එපා. කටපාඩම් කළොත් මේක කරන්න බෑ. හරිද? ඒව හැම වෙලෙම කියන්නේ රීඩින් එක නෙමෙයි. උඩින් පේන දේ නෙමෙයි. රීඩින් එක නෙමෙයි. මෙතන බලන්න ෂිෆ්ට් කරේ කොතනද කියලා. ෂිෆ්ට් කරා නම් මේ පැත්තට ෂිෆ්ට් කරපු විදිය බලන්න. ෂිෆ්ට් කරා නම් අනිත් පැත්තට බලන්න. හරිද? නිසා හොඳට තේරුම් ගන්න. හරියට තේරුම් ගන්න කටපාඩම් කරන්න එපා. කටපාඩම් කරොත් ඔක අමාරුයි. ඔය ඉක්වේෂන් තියෙන පාඩම් කරන්න. ඉක්වේෂන් පාඩම් කළා මේක තේරුම් ගන්න බෑ පුතේ. හරි තේරුණාද? Did you get my point? Everyone, I need your responses.
Yes, sir.
Yeah, sir.
Others? If anyone need a explanation again, please let me know. Minus 1D, 1D නෙමෙයි පුතේ. මේ 4 නේ. Here 4 is okay. I will draw a clear mark. Okay, make it clear නෑ. මම clear කරලා දෙන්නම්. Manner. If this one shifted this direction, sorry, negative. If this one shifted this direction, then positive. If this one is shifted by this direction, it is put in negative. It is negative. හරි. එහෙනම් බලන්න. මේ no zero condition එක. මම same scale මැද ගන්නවා. When you are drawing, please don't do not draw until I say. When you are drawing, please draw as a corresponding lines. May corresponding lines in the other end. Okay. Suppose this one is shifted by 2D. Zero. No need to write this one. මම main scale එක ලියන්න නැහැ. ඒක නැත්තම් ඔයගොල්ලෝ පටලවා ගන්නවා. main scale එක ලියාගත්තොත් ඔක පටලවා ගන්නවා. මොකෙන්ද ගත්තේ කියලා අන්තිමව දන්නේ නැහැ. මේක main scale එකෙන් නෙවෙයි ගන්නේ මේ y scale එකෙන් ගන්නේ. Okay. So this has shifted 2D. This has shifted 2D into this direction. Into this direction. That's why this mark is coincide. Okay. Therefore, error is equal to plus 2D. Error is equal to plus 2D. Second one. මම මේ පැත්තෙන් ගන්නවා පුතේ මේ පැත්තට මම 2D ගන්නවා. So here the zero value. Now here the zero value of this one. Okay. Now this is shifted this direction by 2D distance. 1, 2, 3, 4, 5, 6. 4, 5, 6. Here, those two are constant. Those two are constant. This direction. But maybe it is pushed by this direction. It is pushed by this direction. So error is equal minus 2D. Minus 2D. Okay. Did you get my point? Teriya? Amount of the
Yeah, sir.
So good mark, Bute. Okay. Minus 1D. Suddenly, man. But they have to put the tail. Alright. Then draw these three images. Make a pillow at a Please draw these images very clearly. If you can use a ruler, it is better. It is better. It will be better. Okay, how to get 2D here? 2D can be decided by from here. 6 minus 4. 6 minus 4 is equal to 2D. 6 minus 4 is equal to 2. And so if it is negative error, if it is negative error, that means the vernier caliper is pushed by this side. That means from right to left. The vernier caliper is pushed by this side from right to left. Okay, therefore, if there is a mark, which is coincided with the main scale, the shifted distance can be taken by the difference between these two. එහෙනම් මේ දෙන්නගේ එකක් කඩු කරන්න 6න් 4ක් කඩු කරලා 2යි නෙමෙයි 2D. ඒතකොට 2 into D. And therefore it can be written as the error, it can be written as 6 minus 4 into this. Minus 6 minus 4 into D. That is 6 minus 4 into D. Well, shall I rest? Makan. Makan link එකේ මොකක්ද ප්‍රශ්න තියෙනවද? Link එකේ මොකක්ද වැඩ කරන්නේ ප්‍රශ්නයක් මොකක්ද තියෙනවද? මට වේද? පාර මොකක්ද link එකේ මොකක්ද? Shall I rest? Shall I rest? Okay. Therefore, I can write the positive zero. Positive zero error, it is just as a reading. The positive zero error. Positive zero error is equal the positive zero error. The positive zero error, it is just a reading. Therefore, we can write the number of vernier scale for sorry is the main scale into the least count. Least count into least count. And therefore, I can write this one as n into d. Simple n into d. Simple n into d. And no anything. Well, so this is the first one. Then the negative zero error. The negative zero error can be written as number of divisions in the vernier scale minus the number of vernier scale, the number of vernier mark, the number of vernier mark, the number of vernier mark, not the scale, the number of vernier mark coinciding with the main scale, the number of vernier mark coinciding with the main scale into the least count. මේක කටපාඩම් කරගන්න ඕනේ නැහැ හොඳේ. Therefore, negative zero error can be written as if it is capital N, if it is simple n, therefore capital N minus simple n into d. Capital N minus simple n into d. Capital N means the total number of division in the vernier scale. This is the number of mark. The number of mark coinciding with the vernier scale. The number of vernier mark. Okay, note down this table. Okay, now we have determined how to get the zero error. And how to get a zero error? If it is a positive zero error, then you can directly get the zero error as a reading. But it is a negative. If it is a negative zero error, that means the vernier scale is shifted into the left hand side. Left hand side. If it is shifted into left hand side, you have to take the reading from the other way. That means you have to subtract the actual reading from the total amount of divisions in the vernier scale. Okay, then you can get the negative zero error. Correct? So those are the ways of determining the zero error. Now you can determine the error. Once you determine the error, you have to correct that error. Now you have to you should have an idea how to correct that error. Okay, then write a topic. Zero corrections. Zero corrections. First we have discuss about zero errors. Now zero corrections. Zero corrections. Another topic, the first subtopic is positive zero correction. Positive zero correction. Shall I erase this one? Zero corrections. Zero correction. Uday, please delete the subtopic, just the main topic. Zero corrections. Then I will discuss what is positive one and what is the negative one. Please delete the subtopic. Just write the main topic. Zero corrections. Zero corrections. Okay. Zero corrections. Suppose if there is a positive zero error, if there is a positive zero error, if there is a positive zero error, now here the main scale with it. Now here the vernier scale. Now here the vernier scale. And now this much of reading is already there. This is the error. Positive error. Suppose this is X. This is error. This is a positive error because it is positive. It is positive and it is shifted towards the right hand side. Therefore, this amount of reading is already there. This amount of reading is already there. So, how to remove this error? How to reduce this error? How to do that? That means if I take a reading, this error will be included to that reading. Because this reading is already there. This reading is already there. Now the reading is positive. Now the reading is positive. That means when the two external jaws, are in contact, now there's a reading that is equal to plus C. Now there's a reading which is equal to plus C. Okay. Now the reading is plus C. So if I may expand this one, that means if I'm going to may take a reading, if I'm going to take a reading, now this value also included to that reading. Therefore, definitely, if the reading is 5, it will show 5 plus E. Reading will be equal to 5 plus C. Therefore, definitely, in this kind of error, we have to reduce this value. We have to reduce this value from the reading. Did you get my point? Did you get my point? Hmm? You have to reduce the value from the reading because the reading is already there. The reading is already there. The reading is already there. Therefore, if you may get a reading, this value will be added to the reading. Therefore, you have to subtract that value from the reading to take the accurate answer. To get the correct answer, not the accurate answer. To get the correct answer. No. තේරුණාද? බලන්න. අපි අපි මේකෙන් ගමු වැලුස් වලින්ම ගමු. වැලුස් වලින් ගමු. ඔන්න බලන්න දෙනවා මම වැලුස් වලින් ගන්නේ. මෙතන 0 පුතේ. Now this is the 0 value. This is 0 value. Now there's a reading 5 millimeter. That's a 5 millimeter reading. Okay. Now I have expand these two. Now I have expand these two and insert 5 centimeter blocks. 5 centimeter block. Now I have expand these two and insert 5 centimeter block. Okay. This block has value 5 centimeter. This is 5 centimeter. And this is 5 centimeter. But you can clearly see when the two jaws are in contact, two external jaws are in contact, this has a value 5 millimeter. This has a value 5 millimeter. So if I expand this by 5 centimeter, then definitely now the reading should be 55 millimeters. 55 millimeters because before expanding it has already a 5 millimeter with it. Now it has expanded by 50 millimeters. So 50 millimeters plus the initial reading is 5 millimeter. The altogether the reading should be 55 millimeter. Did you get my point? Therefore now the okay. Everyone, please look at this. Okay. Everyone, please look at this. Now I'm going to discuss about zero correction. Suppose now there is a zero error, positive zero error. Positive zero error means now the vernier scale is shifted by 5 millimeter. So it is shifted by some distance. Before taking any reading, it shows a reading. It shows a reading. Now, this mark, that means suppose mark color pen, mark color pen. These two are coincide. Okay. Now look at this one. This is 0, 1, 2, 3, 4, 5. This one is 0, 1, 2, 3, 4, 5. And the one. Okay. Now two jaws side contact පුතේ. දැන් jaws දෙක contact වුණාට පස්සේ තමයි මෙහෙම තියෙන්නේ. හරි. ඊතර මම jaw එකක් add කරා කියන්නේ. jaw එකක් add කරා කියන්නේ. ඒ කියන්නේ vernier scale එක මම add කරන්නේ. vernier scale එක add කරන්නේ. jaw එකක් add කරනවා කියන්නේ මොකද්ද? vernier scale එක තමයි add කරන්නේ. නේ? Suppose this one. If I move this jaw, if I move this jaw, if I move the sliding jaw, that means I am moving the vernier scale. I am moving the vernier scale. That means I am moving this scale. Put it. I am moving this scale. And this is something like this. This is something like this. Now, then why I meter C do meter C do and then why meter C do not put it. Meter C do not put it. Why meter C do not calling why in Nova meter the hack to the same. මීටර් 10ක් ඉස්සරහින් ඉඳලා මීටර් 100ක් දුවනවා. මීටර් 10ක් ඉස්සරහින් ඉඳලා මීටර් 100ක් දුවුවොත් ඔයා කොහෙද නවතින්නේ? 100 නවතිනවද නැහැ? ඔයාලා නැහැ. Suppose you are running 100 meter event. Okay. Initially you are walk 10 meter towards the upward direction. Then from that point you are going to run 100 meters. So if you ran 100 meters from that point, then the total distance you have run is equal to 110 meters. 110 meters. Then
Yes, sir.
It is something like this. Now it is already start to run. Now it has run E distance. So if I move this vernier caliper, by 5 millimeters, that means the reading, the final reading is 5 plus E millimeters. Did you get my point?
Yes, sir.
Yeah, sir.
100 meters මතක් කරගන්න. 100 meters, okay? 100 meters මතක් කරගන්න. Because මෙන්න මෙයා shift කරන්නේ. දැන් අර මෙතන හිතුවහන් තමයි ඔක අමාරු. මෙතනින් ගත්තා ලේසි. මෙන්න මෙයා තමයි shift කරන්නේ. The vernier scale is the one scale that is movable. There is a movable scale with it. Therefore, if I am going to take a reading, I have to move the vernier scale, not the main scale. Vernier scale. Therefore, I am going to move this vernier scale. And now vernier scale start to run. And it is start to run. So it has already a simple E length. Okay. So if I move another 50 millimeters, then the reading should be equal to 50 plus E. 50 plus E millimeters. Okay. අර රනර්ගේ එකම බලන්න. මම 100 meters දුවනවා. අර 100 meters දුවන්න කලින් මම meters 10ක් ඉස්සරහට ගිහිල්ලා එතනින් 100 meters දුවනවා. එතකොට මොකද වෙන්නේ? අන්තිමට ගියාට පස්සේ 100 meters ලනුවෙන් එහා පැත්තෙම තව මීටර් 10ක් එහා ඉන්නේ. ඒ නිසා මගේ total distance එක වෙන්නේ එතකොට 110 millimeters. හරිද? 110 millimeters. හරි? Okay. Therefore, if there is a positive error, if there is a positive zero error, that means the total reading is higher than the accurate value. The total reading is higher than the accurate value. වෙන විදිහකින් කියනවා නම් if you want to find the accurate value, you have to bring this zero mark to here නේ පුතේ. That is the easiest way to understand. And if you want to take the accurate value, you have to bring this zero mark to here. Is that clear?
Yes, sir.
If you want to bring this mark to here, then what should you do? This much of amount should be reduced, no? This much of amount should be reduced. Otherwise, how to get the zero marks to here? Where? Did you get my point?
Yes, sir.
So then, if you want to correct a positive zero error, you have to bring this zero mark to here. To bring this zero mark to here, this much of amount should be reduced from the reading. Okay. Did you get my point? Everyone, I need your responses. Everyone, I need your responses. Okay. Okay. So to correct this reading, you have to bring this zero value, zero mark to here. To bring the zero mark, you have to reduce this value. You have to reduce this value. Therefore, to reduce this value, you have to reduce the zero error from the reading to it. So if you have this kind of one, now the main scale here, main scale, this is the running scale. Now zero value is here. This is a negative E value. This is negative E value. Then what should happen? So if you want to correct, if you want to get the accurate one, then what should you do? You have to bring this value to here. You have to shift this one. That means you have to add more reading. You have to add more reading because when you shift here, when you shift into right hand side, the reading is added. Reading will be added. When you shift the vernier scale into right hand side, the reading will be added. When you shift the vernier scale into left hand side, reading will be reduced. The reading will be reduced. If you may shift the vernier scale into the left hand side, the reading will be reduced. If you shift the vernier scale into the right hand side, it will be added. Therefore, in this case, the error will be added to the reading to get the correct value. In this case, the error will be subtracted from the reading to get the correct value. And therefore, the correct reading The correct reading is reading minus E. Reading minus E. Reading minus error. In this case, the correct reading is reading plus error. Reading plus error. Hello. So in this case, when we are getting correction, when we are determine the correction, we have to subtract the error. Subtract the error. Therefore, normally we call this as negative correction. Negative correction. If there's a positive error, you should do a negative correction. If there's a negative error, you have to add the error to the reading to get the correct value. Therefore, we call this as positive correction. පටලවා ගන්න එපා. පටලවා ගන්න එපා. මම ඒකයි එක පටලවෙන නිසා මම ඒක කිව්වේ නැත්නම් කපන්න කිව්වේ. පටලවා ගන්න එපා. So this one is called as negative correction. This one is called as positive correction. Did you get my point? තේරුණාද? පැහැදිලිද? පැපලුණා වගේද පැහැදිලිද?
Yes, sir.
හරියට එහෙනම් එච්චරයි. Okay, please draw these two drawings. Hurry. Okay. Write down this thing. If we need to get the correct answer, if we need to get the correct answer, if we need to get the correct answer, or correct reading, if we need to get the correct reading, if we need to get the correct reading, two zero marks should be coincide each other. Two zero marks should be coincided each other. Therefore, the correction is the correction is the correction is the correction is bringing the zero mark, bringing the zero mark of the vernier caliper. The correction is, comma, bringing the zero mark, the vernier caliper. Bringing the zero mark of the vernier caliper to the zero mark of the main scale, to the zero mark of the main scale. Write in another para. Therefore, if there's a positive error, if there's a positive error, we have to move the caliper reading. We have to move the caliper reading to the left hand side. To the left hand side. To the left hand side. That means that much of value, that much of value. That means that much of value, that much of value has to be reduced by the reading, has to be reduced by the reading, has to be reduced by the reading. Okay, then write in another para, write in another para. If there's a positive error, if there's a positive error, sorry, if there's a negative, if there's a negative error, if there is a negative error, the vernier mark, the vernier mark the vernier mark should be shifted, should be shifted. The vernier mark should be shifted into the right hand direction, into the right hand direction.
Excuse me, sir. It should be left hand side, no, sir. The negative one.
Negative one, right?
No, sir. The above one was the negative one.
No, negative.
You have written.
Negative error. If there's a negative error,
Okay, sir.
if there's a negative error, if there's a negative error in the second one, okay, it is better to forget this one. But there are two words in your syllabus. That's why I mentioned that one. If there's a negative, I will repeat it again. If there's a negative error, if there's a negative error, if there is a negative error, the vernier trading, the vernier, I don't know what is the previous word. The vernier scale.
Mark, sir. The vernier mark.
The vernier mark should be shifted towards the right hand direction. To get the correct answer, to get the correct answer, to get the correct reading, to get the correct reading, to get the correct reading. That means that much of amount has to be added to the reading, to get the correct value, to get the correct value. Ah. Did you get my point there now, Aditya? Okay.
Yeah, sir.
Again, I will share the assignment number 1 again. Okay. Assignment number 1 has been shared again. Now, okay. Let's do the third question. Find the zero error of the following cases. The least count of the vernier caliper is 0.1 millimeter. There are 6 examples. I think it is better to draw this one on your book, then do the question. නැත්නම් මේක පුළුවන් නම් printer එකක් තියෙනවා විතර ඕනනම් මේක print out එකක් අරගෙන අලවන්න පුළුවන් නම් අලවන්න මේක වෙනම කතාවක්. නැත්නම් අඳින්න නැත්නම් අඩු ගන්න අඳින්න ඉඩ තියෙනවා. හරි. මොකද එතන කොහොමද තියෙන්නේ ඕන නැත්නම් නිකන් ආන්සර් එකක් දාලා වැඩක් නැහැ. හරි. මේක අනිවාර්යයෙන් මේක තියෙන්න ඕනේ මේ පොතේ. You have to draw this one in your book, otherwise no meaning of getting answers. If you can draw this now, let's do it. Let's do that one. So if you have a facility of taking printout, then you can take a printout and paste that one on your book. Question number 1, Pute. What is the answer for question number 1? Is it positive or negative?
0.6.
Sorry?
Minus 0.6.
Yeah, 0.6. It is negative, like negative 1, therefore 0.6. Yes. The fourth mark is coincide with the meniscus, therefore it should be subtracted by 10. That means minus 0.6. Are there? What about others? Then the second one, what is the answer?
0.6, sir. It is the positive one.
Positive 0.6. Are there? What about others? Is that correct? It is positive, Pute, positive 0.6. Then the third one,
Negative 0.4.
negative 0.4. 1, 2, 3, 4. Yes. Negative 0.4, Pute. Negative 0.4. Very good. Fourth one,
It is positive 0.4.
it is positive 0.4. Very good. Very good. Very good. Fifth one,
Negative 0.3.
negative 0.3. Yes, 0.3. If you may consider from 10th mark, then 1, 2, 3. That means it is negative 0.3. Again, 7 mark again, they coincide with nothing. 10 minus 7 again, 3. 3 into 0.1. Then sixth one,
Positive 1.
yes, positive 1. 0.1.
Sir, can you
No,
say
sorry,
the answers?
1.
Uh,
0.1. 1. And 1. 10 වෙලා තියෙන්නේ 10 එකයි 0 එකයි coincide වෙලා තියෙන්නේ. And positive 1. It should be positive 1.
Sir, can you say the answers from first to last?
Sorry, then
Can you tell the answer from first to last, sir? I wasn't here.
positive last. Okay, I will tell you again.
Okay.
Negative 6, negative 0.6. Okay, negative 0.6. Then positive 0.6. The positive 0.6. Then negative 0.4, positive 0.3, positive 0.3.
3 or 4, sir?
Fourth one.
The fourth one, positive 0.4.
I have third one is Barat and last one.
What's that?
Third one is overlapping. Third one, no.
Third one,
It's
negative
fourth one, sir.
0.4.
Wait a minute. Not a pain enough. Put the third one. Only. Yeah, positive 0.3. Well, third one is coincide with nothing. You know, to open karanga.
Sir, for third one, 10 minus 6, it's 4, no, sir.
No, not third one. Fourth question. The third mark coincide with the main scale, not the fourth mark.
Yeah, sir. Fourth
Hmm?
one it is. Yeah.
So what's the answer for fifth one, sir? Minus 0.3, right?
The answer for the fourth one, should be plus 0.3, plus 0.3, fourth one. Then answer for the fifth one. So what is the answer for the fifth one? Answer for the fifth one, Tagalan.
Minus
Negative
0.
0.3.
Yes, it is negative 0.3. Negative 0.3. 1, 2, 3, negative 0.3. So what is the answer for the last one, sixth one?
Positive 1.
Positive 1. Yeah, positive 1. It has shifted one division, that means positive 1 millimeter. Have then.
Yes, sir.
Then please do the
What's that?
question number 4. Question number 4 and question number 5. Tagdalka. Right. Question number 4 and 5.
Done, sir.
Okay, with it.
Excuse me, sir. I have small doubt in the fifth question. I didn't get what question it is, sir. The fifth
Okay,
one, there are two measurements.
wait. Okay. Shall we discuss?
Okay, sir.
Hurry. So what is the answer for question number 5? Please may type your answer in the chat box. Tagal dan chat box in. Answer see. Tagal. Go, Katti. Nande. What is the answer for the question number 5? Pen nothing. Yeah, what is the answer? Answer. Yeah. It should be equal to 20.3, eh? 20.3. 20.3. Okay. So in the first graph, so here the 0 mark, here the first mark 1. The second mark is overlap. The second mark is overlap with the 1 year caliper the main scale, and it is moving to the right hand side. Therefore, it is positive 0 error. Positive 0 error, and the error is equal to 0.2. 0.2 because the second mark coincide with the main scale. Okay. Therefore, error is positive 0.2. The reading, look at the reading. Reading is 20.5. 20.5 is the reading. Reading is 20.5. Error is 0.2. Therefore, correct reading is the subtraction of these two. That means 20.3 millimeter. Because this is a positive. 0 error. How do you make it? Make an answer. Nand. Thank you. Okay, I will explain it again. Look at the error. Error. So in the main scale, on the main scale, so in the vernier scale shifted into right hand side. Shifted into right hand side, very small amount. And the second reading is coincide with the vernier scale. Sorry, second reading is coincide with the main scale. Mango බලන්න විදිය. බලන්න. මංගව බලන්න ඕන විදිය මං කියපු පුත බලන්න මේ පැත්තේ මේ මෙහෙනුත් ඇවිල්ලා තියෙනවා නම් අන්න එතන තමයි coincide වෙන්නේ. හරිද? එහෙනම් බලන්න මෙයාගේ මේක reading එක කීයද කියලා. reading එක කීයද? shifted distance එක ගන්න ඕනි. shifted distance එක කීයද? 0.2 නේ 0.2 කොච්චර shifted වෙලාද? කොච්චර shift වෙලා මෙයා? මේ මෙන්න මෙච්චර shift වෙලා තියෙනවා. මේ shifted distance එක වෙන්නේ මොකද්ද? මෙන්න මේ distance එක. මෙන්න මෙතන තමයි කොච්චර 2d වෙන්නේ එතකොට. 2 times d වෙන්නේ. second එක නෙමෙයි 2 times d තමයි shifted distance එක. Therefore that is equal to 0.2 millimeters. It is a positive error. It is a positive error because it is shifted into the right hand side. Is this correct?
Yes, sir.
So this is the yes, fourth question. But this is fourth question. This is fourth question. Only fifth only. Fourth question. Haruda, this is the fourth question. Is the error is correct? Everyone, I need to respond to taggal again, Bute. Taggal again, Tamari regarding.
Yes, sir.
Jega तुम्हें देने बोला मुझे paper class से आते ना इतना ही. Taggal again.
Yes, sir.
Alright. The error is 0.2 plus. Plus. Haruda Bute. Alright. Baran reading. Now reading is you can read up to 20. You can read up to 20. Then the 5 is coincide with the main scale. That means the reading is 20.5. 20.5. The reading is 20.5. The reading is 20.5. Now this is the error. This is the reading. As this is a positive error, the reading should be subtracted. Therefore, correct reading is equal to 20.5 minus 0.2. That is equal to 20.3 millimeter. 20.3 millimeter. Harad. Sharad.
Okay, sir.
What about others?
Okay, sir.
Okay, Putin. Now I have to complete today's class, Putin, because there's another paper class for 2025 students from 8:30 onwards. As it is a paper class, I have to log into the class on time. So I have to complete today's class, Putin. Then please complete the tune. Please complete the tune and send that to me. Please complete the tune and send that to me. That is your homework. Okay. Homework is completing your tune. Okay. Then we can complete today's class, Pute. Everyone. Then good night. Abang Pute.
Good night,
Good
sir.
night, sir.
Bye.
Thank you, sir.
Thank you.